Hello Matrix, my name is Retief and I'm a project manager with the South African Institute of Chartered Accountants. Normally at this time of year, we'd be seeing you at your schools or you'd be with us at one of our Tutuga development camps. But because of the situation, we aren't able to do that currently. If you're feeling a bit frustrated and annoyed, we completely understand because we're feeling the exact same way. And we understand how tough it must be without having the extra support to help you through. And whilst we can't be with you in person, we're trying our best to be with you in the only way we can right now, and that's digitally. To help you with your matric revision, the team and I have reached out to some of our favorite educators to create a series of videos in the most common problematic topics that matrics struggle with. We hope that these videos are able to assist you and help you feel less alone during this time. All the best for your matric exams and good luck matric class of 2021.
Good day, grade 12s, and welcome to our session on functions and inverse functions. So a warm welcome to each and every one of you. Please have a look at the pack that you have been given. Looks like this that I've compiled for you guys. We're going to start with that and work our way down. Right, so the first question, I would like to get started straight away. So the first question is a hyperbola given. And the question is write down the equations of the asymptotes of h. So what's going to happen is that the vertical asymptote is going to shift 1 unit to the right, and the horizontal asymptote is going to shift the graph 2 units up. So the equations of the asymptotes is 1 and y equals 2. Right, 412. Determine the equation of the axis of symmetry that has a negative gradient. So a negative gradient. So what I like to do is I like to use the point of intersection of the asymptotes, which is 1 and 2, and then replace y with 2 and x with 1, so therefore c is equal to 3. Right, there are various other ways of working out this answer, but for me that's the best way that I can explain it to you. Right, 413, sketch the graph of h showing the asymptotes and the intercept. Okay. Okay, I'm just gonna go for it freehand. So x equals 1. Let me try my best. X equals 1 and y equals 2. Right. So to work out the y-intercept, we're going to make x equal to 0. So therefore that answer is 5. So that coordinate would be 0 and 5. So to work out the x-intercept, we make y equal to 0. Carry the constant over and multiply by the denominator. Remove the brackets by distributing in the minus 2, so it's minus 2x plus 2 equals minus 3. Minus 2x is equal to minus 5, so therefore x is equal to 5 over 2, so therefore the coordinate is 5 over 2 and 0. So the x-intercept is 5 over 2 and 0. And the y-intercept is 0 and 5. So the reason why I'm sketching the graph in quadrant 2 and quadrant 4 is the fact that the a value is negative. So in the next example, we're going to sketch the hyperbole when it's positive. So therefore it will be in quadrant 1 and in quadrant 3. Right, so let's move on. So f of x, so the next question there, example 2, f of x is equal to 1 over x plus 2 plus 3. As you can see, the a value is now positive. All right, determine the equations of the asymptotes. So 5, 1, 1. So this means this graph is shifting 2 units to the left and 3 units up. Next question, work out the y-intercept. So to work out the y-intercept, x must be 0. So that's 3.5, or 0 and 7/2. 513 is calculate the x-intercept. So to work out the x-intercept, we're going to make y equal to 0. Carry the constant to the other side and multiply by the denominator. Use the distributive law, so we're going to distribute minus 3 in, so it will be minus 3x minus 6 equals 1. So minus 3x is equal to 7, so therefore x is equal to minus 7/3. The coordinate is minus 7/3 and 0. Transfer all of that information onto a system axis. Right, so the vertical asymptote is at minus 2. And the horizontal asymptote would be at 3. The y-intercept is at 0 and 3.5. And the x-intercept is at minus 2 1/3 and 0. Right, so this one is positive, therefore it's going to be in quadrant 1 and in quadrant 3. So I like to sketch the graph from left to right and from left to right. Right, there you go. So it's basically the same procedure every single time by sketching the hyperbole. Alright, next question is the last question on the page. F of x is equal to minus 1/x minus 1. So the only difference here is that there's no vertical shift. So 5.1 it says write down the domain of f. So the domain of the x values. So what are the restrictions on x? Well, x can't be 1. So if x is 1, the graph would be undefined. Write down the equation of the asymptotes of f. So that means the vertical asymptote is shifting 1 unit to the right and 0 up or down. Sketch the graph of f, clearly showing all the intercept with the axis and the asymptotes. Right, so let's try that. Okay, axis again. Vertical asymptote at 1. And vertical asymptote at 1 and horizontal asymptote at 0. Okay, so to work out the y-intercept, make x equal to 0. Shift that up a bit. Y equals 1. Okay, so that's at 0 and 1. And there won't be an x-intercept due to the fact that the graph did not shift up or down. So from left to right, the reason why the graph is in quadrant 2 and in quadrant 4 is because the value of a is equal to -1. First real interpretation question that we have, 5.4, it says for which values of x is x times the derivative greater than or equal to 0. That means where both are positive, right? Or where both are negative. Yeah, so let's have a look at where is x positive. So I like to cover up the graph like that. Right? So to the right of this piece of paper, that is where x is positive. Okay? So while x is being positive, the graph must be increasing because the derivative is positive. So So where the derivative is positive, which means where's the graph increasing? So clearly you can see here the graph is increasing. But over here, x is also positive and the graph is increasing. Right. So the first answer would be between 0 and 1. And the second answer would be where x is greater than 1. So the reason why we're not including 1 because at 1 the graph is undefined. Right, let's move that out the way. So if we look at the second option, minus minus, that's not possible. So where is x negative? So x is negative to the left of the page. But as you can see, the graph is increasing. So that's not true because the graph must be decreasing and it's not. Alright. If I turn over, there are 2 more examples there. And that's where we're going to end the first of our videos. So this one is a little bit more challenging. So as you can see, the first 3 examples was really just to get us started. Alright. So the question is f of x equal to a over x plus p plus q. So the question is write down the value of q. Now q is the horizontal asymptote. So they give us the range. They say y cannot be 1. So therefore the horizontal asymptote should be 1. 6.2. It says calculate the values of a and p. So if I substitute 1 into the q now, it's a over x plus p plus 1. Now, to work out both a and p for 5 marks is going to require a simultaneous equation because you've got 2 unknowns. So therefore, we need 2 points. So the first one is, they say the graph is passing through the origin. So if it passes through the origin, then the point is 0, 0. So that's 0, and then that's 0. Carry the 1 over and multiply by p because the opposite of dividing is multiplication. So minus p is equal to a, and that's equation 1. The second of our points is square root of 2 plus 2 and the square root of 2 plus 1. So y equals a over x plus p plus 1, and the point is square root of 2 plus 2 and square root of 2 plus 1. So replace y with square root of 2 plus 1 and replace x with square root of 2 plus 2. Right, so carry the 1 either side, this one to the right or this one to the left, or cancel them out. So that leaves us with the square root of 2 over a over square root of 2 plus p. I'm going to cross multiply. So square root of 2 times square root of 2 is 2. Square root of 2 times 2 is, that's square root of 2 times square root of 2 is 2, plus 2 times the square root of 2, which is 2 square root 2, plus p square root 2 is equal to a. So that is equation 2. So I'm going to substitute equation 1 into equation 2. So I've got 2 plus 2 square root 2 plus p square root 2, and now replace a with minus p. Group the p's together. Right, take out a common factor on the left and take out a common factor on the right. So divide by 1 plus square root of 2. So 2 equals minus p. So therefore p is equal to minus 2. So to work out the value of a equals minus p. Therefore a equals minus 2. Therefore a is equal to 2. Final answer there. Y equals 2 over x minus 2 plus 1. Right. The last question there is sketch a neat graph of this function. Your graph must include the asymptotes, if any. Right. So let's take this graph and we're going to sketch it. And that's exactly what we did in example 1, 2, and 3. Yeah, I'm going to quickly draw a Cartesian plane there. Right, so the asymptotes are 2 and 1. So the only thing that's missing there is to work out the y-intercept. Therefore, x is 0. Okay, now I'm just going to show you what we've got there. So that's obviously 0. Right? Now the x-intercept will also be 0. Okay, let me just prove it to you quickly. Because remember it said that the graph is passing through the origin. See, if you carry the 2 over, it becomes 0. And we just confirm that our answer is correct. So the graph is going through the origin, which is 0, 0. And it's in quadrant 3 and 1 because the value of a is positive. So there and there. Right, there you go. So example 3 done. So we're going to move over to the last example there, which now becomes to the point where I actually want to get to is when you work with multiple functions on the same Cartesian plane. So what have we got here? We've got a straight line, we've got a hyperbole, and we've got a log function. Right. So question 4, the combination of questions. So this is the first of many that we're going to do. So f of x is equal to log 5x, which is an increasing log function due to the base 5 being greater than 1. And g of x is 2 over x minus 1 plus 1, which is a hyperbole, where it shifts 1 unit right and 1 unit up. The first question there is calculate the coordinates of u. Now to work out the coordinates of u, that is where the log graph is cutting the x-axis. So in order to work out the x-intercept, we're going to make y equal to 0. So you take the base and you raise it to the y value. So 5 to the power 0 is equal to x. So base 5 to the power 0 is equal to 1. So therefore the coordinates of u is 1 and 0. 4.2, write down the equations of the asymptotes of g. So it's this graph. So the asymptote is x equals 1 and y equals 1. 4.3, determine the coordinates of t. Now if we look at the coordinates of t, that is where the hyperbole is cutting the x-axis. So therefore the x-intercept. So to work out the x-intercept, we make y equal to 0. Carry the constant over and multiply by the denominator. Distribute the minus 1 in. Therefore x equals minus 1. So therefore the coordinates of t are minus 1 and 0. 4.4. Write down the equation of h if the reflection of f in the line y equals x. So when you reflect something about the line y equals x, is you need to find the inverse of the function. Alright. So f of x is y equals log 5x. Right? So what you do is you take the 5 and you raise it to that to the y values. 5 to the power y equals x. Now, when you reflect something about the line y equals x, you interchange x and y. So swap x and y. So therefore, y equals 5 to the x. So the equation of h is an exponential function, which is 5 to the power of x. Right. Three more questions. Sorry, my bad. 4.5. Write down the equation of the asymptote of h of x minus 3. Okay, now h of x minus 3 means shift the graph of h 3 units to the right. Okay, now h of x is y equals 5 to the x. Now by replacing x with x minus 3, we're going to get y equals 5 to the x minus 3. So that just moves the graph 3 units to the right. So that doesn't affect the horizontal asymptote. So therefore, the equation of the asymptote is just y equals 0. So this is just to trick you. It's got nothing to do with the vertical asymptote shift. 4.6. It says calculate the coordinates of V. Now to work out the coordinates of V, it's the point of intersection between the line y equals x, because that's what it says. The line y equals x intersects the asymptotes of G at R and the graph of G at V. So to work out the point of intersection, we have y equals x and we have y equals 2 over x minus 1 plus 1. So this is equation 1, that is equation 2. So substitute 1 into 2. So y is equal to x. So replace y with x. Carry the 1 over. And multiply by x minus 1. So that becomes x minus 1 squared. Right, in order to get rid of the square, take the square root. So x minus 1 is equal to plus minus the square root of 2. We'll take the 1 over, so x equals plus minus the square root of 2 plus 1. Now obviously the one answer will be positive and the other answer will be negative. So I've got square root of 2 plus 1, 2,41. Or x equals minus 0,41. Now, if we look at the graph, where are they intersecting? They're intersecting to the right of the origin, which means that this x value has got to be positive. So it can't be negative. So this answer is not applicable. So we are looking at this answer here. So v equals 2,41. And now remember, you can either put it into that equation or that equation. So obviously this one's easier. What is the x value? 2,41. So if x is 2,41, y would also be 2,41. Right, and the last question there is calculate the coordinates of T1 if it's symmetrical about the point R. R is the point 1 and 1. So we want to figure out what T1 is. So to work out the image of T, which is symmetrical about point R, it means that R is the midpoint between T and the symmetrical point. So what I'm going to do is I'm just going to use the classic midpoint formula, where it's the sum of the two x values divided by 2 must give me the middle, which is 1. So x minus 1 equals 2, so x is equal to 3. The other one, the sum of the two y values. So y plus 0 divided by 2 equals 1. So y plus 0 is still y, times by 2 is 2. So the coordinate of the symmetrical image is 3 and 2. Right, so that wraps up our video on the first 2 pages, and stay tuned for the next couple that's about to follow.